see, is this working? Hello? All right. Thanks. So first a warning, my slides are not going to get much prettier than this. It's kind of tough to follow so many really great and amazing user experience designers when you're the security guy. I'm going to show you some cool technologies, I promise, but they're technologies that mostly do their magic behind the scenes. But that's one of the great things about the web today and the HTML5 platform and everything that's going on is there's awesome stuff everywhere you look. I think we're all here today and we're watching on the live stream because we're really excited about the possibilities these technologies offer. But there's one group that's probably not excited about what these technologies offer, and unfortunately that's my fellow security people, right? Almost since HTML5 was born, you can't go to security conference, you can't read the tech press without finding HTML5 listed as one of the top threats to developers, one of the top threats to users, to enterprises, etc. You know, it's framed as part of this out of control spiral of complexity on the web that's going to doom us all to endless malware and cross-site scripting everywhere and all these problems, right? Now, we security folks are kind of grumpy by nature, right? We spend all of our time warning people about the bad things that are going to happen, and we make a better living every year because nobody listens to us. So this is sort of to be expected, but you should be asking yourself, you know, are they right? Should I be listening to this advice? Is HTML5 really a bad thing for security on the web? And I'm here to say that it's not. Now, I've been involved in the web and security technologies and really interested in this stuff since 1994, and despite hearing about Chinese hackers and lulzsec and stuff on the news every night, I think the state of the web from a security point of view is actually better than it's ever been. That HTML5 is what we have to thank for a lot of that improvement in recent years, and it's putting us on a trajectory to continue to improve dramatically in the next couple of years. All right. At the last W3Conf, I gave a talk with Scott Stender of ISAC Partners, and we sort of talked about what's different about HTML5 applications. That means that everyone, you know, client experience designers has to think about in terms of security. And today, I really want to dive deep into some code and look at two specific problems. Show you some real examples of how you can use HTML5 and some of these new technologies to solve script injection vulnerabilities and to build secure mashups, which are two of the big outstanding problems of web security. And along the way, I hope that I'll convince you a little bit and maybe convince some security people if they're listening that HTML5 is a good thing for the security of the web and it's a path forward to help make things better for all of our users. So not to lack ambition, right? Let's tackle the biggest security problem on the web first, script injection, also known as cross-site scripting or XSS, which is probably what you've heard of it as. This is the most common application vulnerability on client-side web applications today, right? And very credible studies by White Hat Security have estimated that its prevalence is at 90% of web applications, and I believe that. And I hope if you're a web experience designer or a web engineer working in this technology in 2013, you have some idea of what cross-site scripting is. You've heard of it before, but if you haven't, in a nutshell, if somebody else gets to run script in your application, it's not your application anymore. Cross-site scripting isn't just about stealing cookies, it's about someone else gets to take over control of your application in the context of your user's browser. And when you combine that with the same origin policy for JavaScript, it means that an XSS vulnerability anywhere on your domain makes all of the resources and assets on your domain vulnerable. So they can run amok in the user's browser, they can do anything, they can be your users to your application, and that's not something we want. We've known about script injection since 2001 as a problem on the web, and we've developed these sort of, you know, server-side best practices to handle it. We have input filtering where we're going to try and recognize content coming in from users, from forums and other places, and strip out things that look like dangerous tags or dangerous characters. And we have output encoding, where before we send content that might include user-generated, you know, code, we're going to try and encode it so that the browser doesn't see that as markup, it sees it as data. And one of the most common complaints you hear from the security community dating way back about HTML5 is that it's going to break a bunch of existing input filtering. It's going to make websites that weren't vulnerable before now vulnerable to cross-site scripting. And, you know, they're right. That's true. There are a lot of new tags. There are a lot of new attributes. There are a lot of new active content types in HTML5 that those old filters aren't going to recognize. And that's something we really try and avoid in the standard space. We don't want to make existing deployed applications vulnerable when they weren't before. But the thing is, all of those filters, every single HTML XSS filter that uses a blacklist today is already broken. And how can I be so confident that they're all broken? Because stuff like that and that gets interpreted by web browsers, HTML4 browsers, and turned into script that can be used to mount attacks. Does your filter check for that? How many browsers did you test it in to make sure that that doesn't run code on your website, right? So these are from a book called Web Application Obfuscation by Gareth Hayes, Mario Heidrich, Eduardo Villanova, and David Lindsay. There's an entire 280-page book full of stuff like that. What I showed you is just the shore of a continent of horror. So, you know, how did they write 280 pages worth of stuff like that? What's going on? And part of it has to do with what are these filters trying to do? These filters are doomed from the start in the HTML4 world because what we're trying to do is on the server side simulate the parsing and execution environment of the browser and the client. But in the past, every single parser operated differently. The way that they worked was a secret. Every browser was full of proprietary features and tags. And it was actually a feature, it was a good thing to try and accept as much bad markup as you can. You know, there's the Postel's principle. It says be liberal in what you accept. And so browsers were actually competing to do things like that. And it wasn't until HTML5 that we started to see some of this change, right? The security improvements in HTML5 actually start at the very foundations of how browsers work in the parsing engine, because HTML5 is the first of the HTML specs to define a normative state machine, including error conditions, for how to handle markup. And so if you want to understand for the first time, you can find out and you can have some reasonable confidence how browsers parse markup, and you can expect that most of them are going to work in pretty much the same way. The result of this is that coercing a shambling amount of white noise into an application is no longer a competitive feature. And this is kind of a key insight that goes well beyond just parsing, right? Because by standardizing the technology for building rich web applications, HTML5 began a fundamental shift in the security posture of the web as a platform, right? One of the biggest false charges I see leveled against HTML5 is that it's insecure because it's more complex than HTML4. But that's not the right comparison to make, because HTML4 was never really by itself the platform of the web. Rich web applications have been around with us for 10 or 15 years, but they were built in terms of combining HTML4 with other technologies like Java, Flash, and ActiveX, right? And if you're the creator of one of these proprietary rich web app platform plugins, whether it's special features in the browser or a plugin loaded externally, you need to attract developers to your platform. So you live and die by how much you let developers do, not by how many security restrictions you put in their way. You compete for developers by offering them cool things to do, and once you have them locked in, you have very little incentive to change or fix your features. If I'm a developer and I'm decided I'm not happy with Java's security record of late, I have to rewrite my whole application to switch away from that platform. And if I'm a user, I don't have any choice at all, right? I just have to take applications on the platform that are delivered to me. Whereas if I was looking at an HTML5 application and I found that my browser had the same kind of security record that Java's had this last year, I could switch my browser in a heartbeat, everything would just work, and the developer wouldn't have to change anything. So we have a big shift in the incentives driving the features of the web platform from a security point of view, where the proprietary platforms were competing for developers by offering them features, and the open platforms are competing for users by offering quality. And one of the big features of quality is security. And you see browsers, Chrome, Firefox, IE, Opera are all competing every day in terms of who can be the most secure. So a little bit of a digression there, a little bit of a soapbox. We were talking about solving script injection, right? We'll go back to that. So even if now in HTML5 with the normative parser we have some hope of understanding how the browsers are going to deal with all of this markup that we're throwing at it, that's still not necessarily the best or complete approach to solving the problem of cross-site scripting. It's not easy. These are still really complicated things to try and engineer. They're definitely not future-proof. And one of the things about HTML5 applications is that there are new data flows being introduced that the server never sees. If I'm making cross-origin requests with XML HTTP requests, if I'm pulling in content from other application instances in the browser, or if I'm talking to another browser using something like web real-time communication, those flows never traverse my server. So if I try and put all my protective logic in the server, I'm going to miss things. So why don't we ask the client for some help? The problem is that the client, the script execution is happening there. Let's do something about that. And so a couple years ago, Mozilla invented content security policy and put it out in some early versions of Firefox, and then eventually contributed to the W3C, and we took it up in the Web Application Security Working Group. It's now available unprefixed with the candidate recommendation in the Chrome Beta 25. There's a reasonably complete implementation of almost everything in Firefox since version 6. And there are prefix versions available in both mobile and WebKit Safari. IE10 has a partial implementation only of the sandbox, which we'll talk about a little later. And what content security policy is a header to tell the client to enforce a least privilege environment on your application. And it turns out this isn't actually a new idea at all, right? So in Homer, there's this story about Odysseus, and he wants to do something dangerous. He wants to listen to the song of the sirens, so he tells his crew, tie me to the mast of the ship, and no matter what I say, no matter what I do, no matter what I offer to you, don't untie me, because I'm just going to jump in the water and drown. So tie me to the mast and don't listen to anything I have to say. And basically that's what content security policy is. It's the way that your application can tell the browser to tie it to the mast. And here's an example. Let's say I was writing, a message board and I wanted to let my users post rich content. And that's a dangerous thing. I can't write a super restrictive filter because I want to let them do cool stuff. But I want to keep it within some boundaries so that I know that my application is reasonably safe. So we have here the header line content security policy, and then we set a default source of self. And what that's going to say is, by default, all this other stuff that might get included into my page, only accept it if it actually comes from the same origin as the application itself. And I'm going to have a line, next line says object source none. Basically that says don't load any plugins. My site is not going to be hosting the next Java drive-by malware installer, because if the browser sees any tags to load Flash or Java or any other plugins, it's just going to ignore those. Those are probably injected maliciously. They're not part of the application's design. We can have some other things here telling about where we're going to load images from, where we're going to allow external script to be loaded from, where we might allow some frames to have videos, but only from YouTube, maybe Vimeo or some other competitors. But we don't want to just let arbitrary content from any place that's not controlled and policed into our message board. And then we're going to send reports whenever any of these violations happen back to a script that we have that's going to collect that on the server side and let us analyze what happened with content security policy. And this is basically a full list here of all the directives that we support in Content Security Policy 1.0. So you can see there's a reasonably good set of features that you can take control of in the browser and put into a least privilege environment. The catch here is that in order to make this meaningful, you have to have a good separation of code and data. And so Content Security Policy enforces this by default. And what this means is no inline scripts and no inline CSS, and no eval even in JS libraries that you load externally. You can disable these features, but if you do so, you're going to sacrifice a lot of the benefits of Content Security Policy. So here's an example of some typical code that is not going to work under CSP, right? We have an inline script that's creating a function, and then we're going to have an event handler attached directly in our markup that's going to call that. So we can restructure this pretty simply by having a separate JavaScript file that's going to define our event handler function, and then we're going to go through the DOM and we're going to look for elements of a certain type and attach our event listeners to those elements dynamically. So we're going to have a good separation of here's our markup, here's our styles, here's the activities and actions and interactivity in JavaScript that we're going to attach to the page. And so this is something that's CSP compatible, and you've been able to do this pattern for a long time, but most people don't, right? Let's be honest. This is very uncommon, and one of the reasons it's uncommon is you don't get any benefit from it. It's architecturally clean, but you can still get injected. Now for the first time with CSP, you can tell your browser, I'm using a clean design pattern and I want you to enforce that it stays clean. Don't pay attention if there's other stuff in there. Still as difficult. That's great if you're building a new application, but it's harder for legacy applications. So in the next version of Content Security Policy that we're working on right now, we're looking at ways that we can allow whitelisting of inline content, either tag it with a nonce or tag it with a hash and say, I want to allow this specific well-known script to run inline or the specific CSS script to run inline. So that helps us make this policy applicable to legacy applications, make it more compatible with the ways developers typically write applications. And there's one more feature I want to touch on briefly. It's still kind of on the horizon, but that's templating in terms of stopping cross-site scripting. And templating technologies are one of the oldest and most common ways that we have of building applications, right? ASP, JSP, FreeMarker. There's a dozen different template systems out there, but they're all kind of suffer from lots of cross-site scripting problems because the templates are trying to do the same things these filters are. They're trying to simulate and understand what the browser environment is going to do in terms of parsing and execution, and they're not well equipped to do that. So again, we can ask for some help from the client side. And so Google and Microsoft are pushing forward this new standard for HTML templates in the browser in the Web Apps Working Group. And that's going to let you declare templating, HTML template snippets as first-class objects in the browser DOM and use them in a way then that is safe against cross-site scripting and that is compatible with CSP. So at the end here, we're about 15 minutes, 20 minutes in, and we've shown already how you can solve with CSP in a modern application architecture the most common problem of web application security today. And in the near future, you're going to be able to solve it much more easily using common idioms, using more performant methods of coding and things that you're more comfortable with today. So we've solved XSS. It's not a bad day's work, but we're not done yet. So secure mashups are one of the other things that really is a key to the modern web. And it's one of the other complaints that security people have about HTML5 is that there's all these new ways to bypass the same origin policy, and this is all going to end in tears, they're afraid. And what is a mashup, right? I think we all kind of know here we're design types. It's anything that incorporates content from different sites into a single application. And we're all familiar with anonymous mashups, putting Craigslist apartments onto a Google map. But I think maybe not everyone realizes that almost every major site we visit on the web today is an authenticated mashup. We're sending cookies to different sites and we're getting content that's customized to us and exchanging data between different origins and combining that into almost every application we do because we're doing things like federated login, we're doing advertising where we're being tracked, and we're doing things like analytics. And so this is going on everywhere today. It's been going on for a while. How do we do it before HTML5? We could use Flash. Flash has a policy file, cross-domain.xml, that lets us say, Swift can go out and read this file on my domain and it can see if it has permission to make requests and read the results. So this is an example policy file that lets a Swift from exampleanalytics.com connect to foo.com and send requests with cookies and read the results. But we security people are cynics. My friend Jan quipped to me on Twitter the other day, he's like, give someone an ACL and they'll put in a star. So what happens if you put a star in your cross-domain.xml? Bad stuff, right? If you put that in your root policy file, you've just given every Swift on every malicious site on the internet the ability to basically act as your users against your site, compromise any of their data, read all of their resources. Not a good thing. And probably a lot of people in this audience are also thinking, well, yes, Flash is great, but I'm writing for the iPad, I'm writing for the iPhone, I don't have Flash available everywhere. What do I do this in just HTML? And the answer is that there's always been, since the same origin policy was invented, there's always been a loophole, the script source loophole, where if I load content and then I pull in script from a foreign origin, as that script executes, it becomes part of my application, part of my security context and origin. Right? And so we can use this as a communication channel because we can effectively read the content of the script sent to us from this other domain that we've pulled with the user's cookie. This is also commonly known as a pattern called JSON-P or JSON with padding, where we say, I'm going to get, instead of script, I'm going to get JSON and it's just going to be padded with a function call. But the catch here is it's still not just data, it's really script. This pattern, this integration pattern, is injecting someone else's script into your application, injecting someone else's code into your application. And maybe you remember a couple slides back when I said what the definition of cross-site scripting was. So, but, I've been upset about this for years, right? I've been telling people don't use this pattern for a long time, and everyone says, no, it's okay, we trust these people we're sourcing the script from, we trust Google Analytics, we trust Facebook, it's all fine. Nobody listened until 2 weeks ago when Facebook broke the internet. Did anyone see this page a couple weekends ago, right? You went to like a huge chunk of the web, and instead of seeing the site you expected, you saw this Facebook error messages, right? Do you want to see the line of code, the one line of code that broke the internet? Oh, there it is, right? Because this is the integration pattern that Facebook Connect is using. Go to Facebook, grab their chunk of JavaScript, throw it in your application. And so if anything goes wrong in that chunk of JavaScript, your application blows up, right? And still, this was just a bug. This was an innocent bug. This wasn't Facebook trying to hack your application. Do we have to worry about that? Well, this was on the news a week later, that Facebook had compromised, well, not by an HTML5 zero-day, by a Java zero-day. That's worth noting. These aren't connected, obviously. I don't mean to imply that they're connected, and I'm sure that Facebook has really strong security measures to prevent a developer workstation being compromised from leading to compromise of code on the front end. But it's something that should give you pause, right? You should be thinking about this. Because the more we use these kind of script injection patterns to integrate the web around a few really important places, the more brittle we make the web. And the more high value a target those APIs, those integration points become for the bad guys to attack, and the more determined they're going to be to attack them. So this is a big risk, and we sort of finally have seen it start to appear. But luckily, we can build it better. We have the technology. And cross-origin resource sharing is the first way to do that. And this has very, very broad support across a large number of browsers right now. It's been around for 4 or 5, 6 years, and it's integrated almost everywhere. IE is the only lagger. They just have supported cores with credentials in the last version. They support an earlier version in IE8 that only allows anonymous requests, which isn't as useful for these patterns. But basically, this lets us voluntarily relax the same origin policy to allow cross-origin data exchange using some headers, and those headers can control whether we use credentials and whether and what origins are allowed to read and share our content. And here's an example on the client. It's actually really simple. It looks just like, for the most part, an ordinary XHR request. You don't have to do any of that work as a consumer of a CORS API. It's almost all handled for you by the browser. And you see what we get back here is not a piece of script. We get back text. And so we can call a validation function on that text. And if something goes wrong on the remote API, it doesn't necessarily blow up our application. So the key difference here is that a script source pattern gives you code you have no choice but to trust. CORS gives you data that you can verify. And what about the star, right? We saw the star is dangerous, and this is one of the things that all security people love to harp on is the star in CORS. Beware the promiscuous asterisk, they call it. But what they haven't read is that, you know, a mentor of mine told me the security person's job is to keep reading the spec a paragraph after the developer has stopped. And I think that more security people need that advice. If they had read the whole spec on CORS, they would have seen star is not allowed to be combined with credentials in CORS. And that means that, you know, no cookies, no auth headers, nothing like that. So, whereas if you had a star in your cross-domain XML file that gave any site access to your data as if they were your users. If you have a star in CORS, they can only see the same thing that they could see from their own server. So actually star is one of the safest ways to use CORS. It's one of the safest patterns. If you have public resources that aren't authenticated, go ahead and throw an access control all origin star in there. It won't hurt anything. So that's great if you're talking to a website that cooperates and publishes a CORS API. What if they don't? Right? What if we still want to consume that JavaScript file as an integration pattern? Well, we have two other technologies that are going to allow us to do that. Sandbox iframes, which are widely available, although we'll see that you can do most of this stuff with just a regular iframe and still get a lot of the benefits. And then a new API called post message, which lets us send and open a channel between two different application instances of different origins in the same browser. So here's how we set it up. We're going to create, you know, foo.html and trusted.mydomain.com is going to be our main web page. We're going to create an iframe in there, and we're going to load into that iframe some other content that I control, another page I've written, but I'm going to put that on another domain. I'm going to put that on integration.mydomain.com. And the iframe sandbox, if it works, if the browser knows about this, is going to totally isolate that content, put it in a unique origin with it, you know, just assign a random GUID to it, and keep it from doing anything malicious to the parent page. But this trick here of changing the origin is going to accomplish a lot of that in any browser because of the way the same origin policy works. Then what we're going to do in the code that we load into that iframe is we're going to make that, you know, script source include call, which is going to run that code in our application context here. Let's say it's going to set a variable called login name that's going to tell us what the login name of the user is. And then we're going to call post message and send that back up to our parent that's hosting us. And we're going to check the origin and say, make sure that this message is only going to go to the place we expect it in case some malicious site decided to host us as an iframe. We can say, well, we want to control what origins these messages are passed between. And then back on our parent page, we can receive that message, you know, create an event handler, check the origin of the message, and what we get is a string, and we can apply validation to that string. So again, we've safely isolated that code into a jail, and we've let it pass notes to us instead of running rampant. And we can use this pattern then to safely use these legacy application integration patterns in modern web apps. But there's more to this pattern than I first realized. I talked about this, I introduced this briefly in 2011 at the W3Conf, but I didn't think through how important it might actually be, right? I didn't realize this until I saw a talk at last year's Usenix Security by dev.akwe. And in one of those brilliant insights that seems really obvious once you've heard it, dev.a realized that this wasn't just a useful trick for isolating mashups. That what we have here in this iframe and post message construction is actually a fundamental building block for privilege separation in HTML5 applications. What he said was basically, if I treat my own code and libraries that I host on my own domain as potentially hostile, potentially dangerous, I can put them in that same kind of jail. And what that means, if I'm building a complex application with tens of thousands of lines of JavaScript code, there's bound to be latent bugs in there. There's bound to be security issues I haven't found. I can hide those all in that same kind of jail, and I only have to have the very small core of my application that does trusted operations with things like the user's cookies and completes transactions run in the original security context. So what that does, he actually tried this out, right? He looked at real applications using real libraries, and with just 10 or 15 lines of code, he was able to take applications that had 1 million lines of code and reduce their trusted computing base by 95%. Isolate all those bugs, hide them all away. So, very simple pattern, very easy to write. I think it actually will be able to make libraries that can do this kind of analysis in an automated fashion and hide this completely from developers in the near future. So that's very cool. I would encourage everyone to go check out this paper. I think if it gets the attention it deserves, it could be one of the most important 10 papers in computer security in the decade. So, simple trick, vast improvement in application security, lets us build complicated things safely. So, in summary here, HTML5 and the Open Web Platform are improving the security of the web ecosystem. They're pushing out the insecure plugin architectures that have dominated the vulnerability space in the last decade. And the rich applications we're building aren't actually new. They're not new complexity. We're replacing other technologies that had more complex models, more risk, and more cognitive load for developers. We have tools at our hand today to solve some of these big persistent problems like script injection. And we're working on ways to make those tools more accessible, more applicable to existing applications and comfortable patterns for developers. And we can avoid some of these pitfalls of trying to simulate on the server side a complex client and just enlist the client's help directly in securing our applications. And on the mashup front, we have CORS technology, which is widely deployed, that we can use to get data instead of code for our integrations. And we can use iframe and post message as a fundamental building block, not only to secure our mashup applications, but to build a privilege separation architecture in our own code that mimics the kind of architecture we see when we're architecting a secure browser or a secure operating system, but in a way that's actually much simpler to do than those privilege separation techniques on those traditional development platforms. There's a lot more I could have talked about if I had more time. We have a lot of ongoing work in the Web AppSec Working Group. Content Security Policy 1.1, as I said, is still undergoing active specification, and we would love to have more input from more developers, more people writing code as to what are the actual problems you have, and get some ideas on how we can make this more easy to apply, more accessible for everybody. We're working on a new deliverable called User Interface Safety that we hope is going to allow us to kill clickjacking, which is a user interface context attack that affects applications and iframes. And we're working on another deliverable soon. We're going to start work to allow you to load resources into secure applications that were loaded over HTTPS and pull in things like giant JavaScript libraries, images, and things, and maintain integrity even if you load them over an insecure channel. So try and take away some of the perceived user performance penalty of HTTPS and bring caching back into that layer. And there's also a lot of cool and important work underway in the Web Cryptography Working Group, and there's a whole other talk I could do about why the security grumps are wrong about that too. But that's it. I think we have a few minutes here for questions.
So you were talking about like allowing scripts using a nonce or things like that. What about stuff that's cached? What about stuff that's like on a CDN or something where you can't necessarily predict what the URL is, like if it's automatically injected, things like that?
So external script that's going to be pulled in through script source, we can already handle all of that today with content security policy. You can specify, the entire server, or in content security policy 1.1, you can specify a directory. So you don't need to know the whole URL for stuff
great.
that's remotely included.
Thanks.
Thanks for the talk, Brad. This is great. How would you go about preventing what happened with the Facebook script? Is there anything that we could do to prevent that in the future? Like, I guess like what kind of verification would you do?
Well, the biggest thing is just you treat it as data instead of code. So if there's an error condition, your application is in charge of reading that. You're going to get some value back. You're going to get maybe some piece of markup back, and you can look at it and say, is this sane? Is this what I expect it to look like, or is this a redirect to some error page that I don't want to follow?
Sure.
So it's a matter of, first of all, the people deploying these integration patterns should take the responsibility to offer them in a secure manner, using a pattern like CORS. But if you're the consumer of that, you can protect yourself by isolating it and treating it as data instead of just accepting code into your application.
Yeah, I think what I was thinking about is, oh man, this means that I'm going to have to constantly stay up to date on all these different third-party things and make sure that, I'm checking them the way that they're expecting them to work and things like that. But if that's the more secure way, then that's
there's certainly some convenience to just accepting
right.
constantly updated code into your application, right? But another way to think of that is what you're doing there is you're allowing Facebook or whoever unconstrained check-in rights to your application's code base. If
Sure.
you're okay with that and you're willing to take the risk, that's something you can do. But I think most people, when they think about it that way, like I'm just letting them check code into my code base anytime they want, maybe you want to have a little more control over that. And one of the things we're doing with CSP 1.1 or with the sub-resource integrators, you'll be able to mark a remote source you're including and say, I only want to load this if it matches this hash. So you'll have the ability to guarantee that that wasn't tampered with maliciously, say, and you can control your upgrade path if you want. That introduces some brittleness, but it's a trade-off.
So is that something that, like Facebook, for example, could provide the hash, almost like a security key, and you could verify against that if you trust that?
Yep.
Awesome. Okay, thank you very much.
Mm-hmm.
Thanks very much for your talk. Two questions, one quick, one medium. Is your presentation online? Somewhere we can reference it?
Not yet. I just finished it this morning, and I'll be putting it up soon.
Okay. Well done, and looking forward to it. Second question is, you opened your talk saying how all these people were saying HTML5 is one of the top threats to security in the web, and I really appreciate your talk, really appreciate all these examples, because I feel like this is something that we're still fighting. 2 years ago, there was an article in the New York Times about HTML5, super cookie, all this kind of stuff, and they didn't mention Java at all. And luminaries in our industry, like Douglas Crockford, have come out saying, oh, HTML5 is bad for web security, respected people. So, second question is, do you have like 3 points that we can use to just address or just dispel this myth that's popped up about HTML5 and web security? Or, what quick way can we argue against people citing these, respected sources?
Sure. I think the first one would be you have to make a fair comparison, right? Like I said, the fair comparison is not to HTML4. The fair comparison is to HTML4 plus ActiveX plus Java plus Flash plus QuickTime plus you name it, right? That the total complexity of HTML5 is actually much reduced for building a web app compared to what we used to have. And the cognitive load on developers to get that right is much reduced. We have one model, we have one same origin policy, we have one set of technologies you need to become an expert in to do this right, instead of 3 or 4 or 5. And then it's that incentives thing. Let's see if I can get my mouse to actually move on this tabletop. But the biggest difference is, I would say, if I had a one-liner, it is this, right? Proprietary platforms compete for developers by offering features, and open platform implementers compete for users by offering quality. And that's the biggest driving factor between why Google has to offer people $100,000 to submit a bug that escapes the sandbox in Chrome these days at Ponium. And if you go back 10 years, every 2-bit spammer in the world had a no-day that could pop Internet Explorer and install a toolbar and malware on your system. And, it cost $50 to, buy a no-day back then. So those would be my 2 big points: fair comparisons and looking at the right incentives.
I just wondered if there's any work going on about, with regards to security around local storage and IndexedDB and that kind of thing. The reason I ask is that you often want to store in local storage or IndexedDB data that's associated with a particular logged-in user. There's no way of linking the two because their session expires when they shut their browser. There's no hook into that, and so really we can't do much with it yet in that regard, and it's kind of rendered it a little bit useless for us. Do you know, is there any progress there?
I can't speak to that. I don't know of any work going on in that area, but certainly, and that's one of the great things about the open process we have with W3C is you can raise that as a problem on one of our lists and contribute API suggestions. So I would encourage you to reach out and join one of the groups or contribute to the conversation on that.
Okay, cool, thanks.
Thanks. Guess that's it. Thanks, everybody.